Hi everyone, welcome to the fundamentals of Android section. In this video, we will be going to see about Android runtime. What is Android runtime and how it is used into the Android ecosystem. Alright. So Android apps are usually written in Java and then compiled to the Dalvik bytecode, which is kind of different from traditional Java bytecode. So whenever developers build the APK file, it contains different Dalvik executable file, which is also known as DEX files. Now, this DEX files contains compiled source code of the application, including all the libraries. So what Android runtime does, Android runtime converts bytecode into machine code. Android runtime is basically a successor of Android's original runtime, which was known as Dalvik Virtual Machine or DVM. The key difference between Dalvik Virtual Machine and Android runtime is the way the bytecode is executed to the machine code. Android runtime also manages the memory and garbage collection section. Let's talk about past. So in the early days of Android, the phones were not so powerful as of now, so it has very little RAM. Dalvik was designed to solve the problem of RAM usage. For that, Dalvik comes up with just-in-time compilation strategy. So instead of compiling the whole application to the machine code, what it does is compile a small chunk of code during execution of the app at runtime. So works kind as an interpreter. But what happens over there that with phone getting more and more performant and more computational power is introduced, it contains more and more RAM, and the application is also getting bigger. So developers need to think again as about the performance of the application, which is kind of a bottleneck with the hardware getting advanced. So to further improve the performance, Android introduced Android Runtime to replace the Dalvik virtual machine. So ART comes into the picture. Now, ART uses a strategy called ahead of time compilation. Right? So what happens in this? The code was compiled before running the application. So this approach is somewhat like improved runtime performance significantly, somewhat like 20 times faster compared to the just-in-time compilation. But there are drawbacks for this also. It introduced high memory usage. Whenever the application is getting installed, it takes more time. Update time is increased. So it's a good approach to precompile the classes, but it comes up with their own drawback. Because just in reality, most of the part of the application is rarely used. So to overcome the problems, GIT was introduced back from Android Nougat with something called profile guided compilation. Now what is profile guided compilation? It helps constantly improving Android app performance as they run. Now how it helps? First of all, the app is run using GIT, just-in-time compilation. So as soon as Android runtime detects frequently you can say running classes and methods of the application, ART precompiles and cache those methods to achieve the best performance. So yeah, it is kind of considered as hybrid approach. So other parts of the application remain uncompiled until they are used. Now this strategy allows best performance with minimum RAM usage. Now ART does not affect on install time or system update time. Precompilation is somewhat like done when the device is idle and charging to minimize the impact. Now, to improve the user experience further, the concept of profiles in the cloud was introduced. So the idea was basically this approach is that most users use application in a similar way. Now we know that if you are using an application, most of the users will use that as a similar approach. So in order to improve performance right after the installation, just because in the previous approach, what happens is initially it was starting with GIT, and then after certain data collection, it will cache those classes which are frequently used. So right after installation, we can collect the profile data from people. So what happens over here is we are collecting the data from the people who are already using the application. Now what we will do, this aggregated data, we will use a file called something like common core profile of the application. So it is kind of an analysis of available data, and after analysis there is some outcome which is a file which is common core profile of the application. So whenever new user install the application, the file is downloaded with the application itself. Now ART uses these pre-compiled methods and classes that are frequently used by most of the users of the application. This way, a new user who is installing the application gets better performance right after downloading an application itself. So it's a win-win situation, right? All right. Hope you understand about ART and fundamentals of ART and how it is used. Thank you for watching this video. See you in the next video.